Hi everyone, in this video we are going to discuss about the concept of a unit circle and the definition of sine and cosine function and what they mean. So let's get started. Suppose we have a circle drawn with the center being at the origin on the Cartesian coordinate plane, and let's assume that the radius of this circle is r unit. Before we go to the unit circle, first I want to start with a circle whose radius is r unit, and then we'll see what the problem is, and then we'll change the r to 1, and then we'll see the benefit of it. So for now let's assume that the radius of this circle, which is centered at the origin, the radius of this circle is r, and then let's assume that we have created an angle theta, a positive angle theta, whose terminal side intersects the circle at point P. And let's assume that the coordinates of the point P is x comma y, right? So the point P is at x comma y, the radius of the circle is r units, and then clearly you can see that if we name this point as Q, suppose I call it as Q, then OQ would be equal to x units. From origin up to that point it will be x units, and then from Q to P, so the PQ distance would be the y units. Now if you think about the sine of theta angle, now we have a nice little right triangle here. If you think about it, our OPQ, that is a nice right triangle where the right angle is OQP, the angle OQP is the right angle, and OPQ is a right triangle. And if you think about this right triangle, and if you think about the sine and cosine of the theta angle, so sine theta would be obviously opposite side, which is the PQ side, divided by the hypotenuse, which is OP. So that's why I have written here that sine theta is equal to y divided by r. R is the hypotenuse and y is the length of the opposite side of theta angle. And similarly, what is the cos theta? Cos theta is adjacent side divided by hypotenuse. In this case, adjacent side of theta angle is actually the OQ side, which is x units. So it would be x divided by r. And now the mathematicians started thinking that, say, hey, to make things easy, can we somehow make the denominator disappear? You know, the denominator that we see right here in the sine and the cosine of theta, the denominator is r, the radius of the circle. So the mathematicians said that, hey, you know what, let's change this r to 1, and then it's going to give us a nice opportunity to define the sine and the cosine function. So we are now changing r to 1. So if we say, hey, r is equal to 1, now let me make a quick little note right here. So now we are going to say that r is equal to 1. So I am now writing r is equal to 1 unit. Let's assume that the radius is actually 1 unit. Then this circle will be called a unit circle. Why unit circle? Because its radius is unit. Unity is 1, right? Its radius is 1 unit, so we are going to call it a unit circle. If we now impose this rule that, hey, let's assume that the radius of this circle is 1 unit, then we are going to call it unit circle, of course. And then let's see what happens to our sine theta and cos theta values. Well, the sine theta and cos theta value then will become, so the sine theta will become y divided by 1, which is equal to y. Okay, that looks very nice. Similarly, cos theta will become x divided by 1, and that will give us x. Alright, so this is excellent. So now what we can do, that we can define the coordinates of this point P, which is the intersection of the circle and the terminal ray of this angle. We can define the coordinates of that point in terms of sine theta and cos theta. So what will be the coordinates of this point? Well, we can say, okay, if we write it as P as the point and its coordinates are x comma y, so we can say it like this, that P with the coordinates x comma y is nothing but it's actually congruent to or same as, we can say same as, in place of x we can write cos theta, and in place of y we can write sine theta. So let's write it down right here. Let's see how it looks. So we can say, okay, the coordinates of P can also be indicated in terms of cos theta comma sine theta. So we can say, okay, the coordinates of P is now cos theta comma sine theta. So here comes the definition of sine and cosine function. So when we have a unit circle like this and we have an angle whose terminal side intersects the circle at point P, we can say that if x is equal to sine theta, then that is the sine function. The sine function will represent the x coordinate of that point. So we can say, okay, the sine function represents, so the sine function, let me write it down here, the sine function will represent the y coordinate of the point, and the cosine function will represent the x coordinate of the point. and also we can say, y coordinate of P and x coordinate of P. Right? So this is how the sine and cosine function are defined. So the definition here says that anytime on a unit circle, if there is an angle theta whose terminal side intersects the circle at point P, we can represent the point P in terms of sine theta and cos theta. The y coordinate will be sine theta and x coordinate will be cos theta. So those are the sine and cosine function, and with this definition it really does not matter where the P is, whether the P is in the first quadrant, or even for a for an obtuse angle the P could be in the second quadrant, for a reflex angle the P could be in the third quadrant or fourth quadrant. No matter where the P is, if we find out the coordinates of the point P, the y coordinate will always be equal to sine theta and x coordinate will always be equal to cos theta, or in other words, sine theta will be equal to the y coordinate and cos theta will be equal to the x coordinate of that point. And the point is very important. It is the point that is created at the intersection of the circle and the terminal side of the angle, right? So now if we draw another angle, for example, so let me draw another angle in the second quadrant, right? So let me draw a second quadrant angle. So here I have drawn another angle which is the alpha angle. It's an obtuse angle. Its terminal side is in the second quadrant and it intersects the circle at point Q, and I have indicated the coordinate of Q as x sub 1, y sub 1. So you can clearly see that if we name this point as R, suppose this point is right here, this is R. So OR would be the value of x sub 1 and QR would be the value of y sub 1. Now here also the coordinates of this point will be denoted by the cosine and the sine of this alpha angle. Well, actually if you think about it, the sine and the cosine of this alpha angle would be x sub 1 and y sub 1. So let me write it down here. So cosine of alpha would represent x sub 1 and sine of alpha would represent y sub 1. If we go with the original definition of the sine and cosine function, we have a point Q on the circumference of this unit circle and the coordinates of that point would be cosine alpha, sine alpha. Right? Now if you think about it, the x sub 1 will also be the cosine of this other angle that now I am going to highlight with a double yellow arc right here. That if you think about this angle, let's call it maybe beta angle. Let's call it beta angle. So the x sub 1 will also represent the cosine of the beta angle and y sub 1 will represent the sine of the beta angle. So now here comes another angle. Well, we are talking about the alpha angle, which is an obtuse angle, and now here comes another angle in picture now, and this angle is also going to give us the same cosine and sine value. So this cosine alpha, which is x sub 1, this is also similar to cosine of beta. If you think about it, it will be like that. Cosine of beta will be x sub 1, and similarly sine of alpha, which is y sub 1, that is also equal to, that will be equal to sine of beta angle. So now this beta angle is actually called the reference angle. I have already created a separate video on angles, the entire concept of various angles. Feel free to watch that video, and at the end of that video I have explained what is a reference angle. Now in this case, for the angle alpha, its reference angle is beta. Beta is the reference angle, and that is why you see the cosine of alpha is actually same as cosine of beta and sine of alpha is same as sine of beta. So the coordinates of that point is essentially, so we can say the coordinate of Q is cosine alpha, sine alpha. Also at the same time we can call it cosine of beta, sine of beta. So let me write down the coordinates of the Q point. So Q can be denoted as, so as you can see, the sine and cosine of alpha will actually or can actually be represented in terms of the sine and cosine of its reference angle, which is the beta angle. And that is the beauty of this unit circle, right? So if somebody says, hey, what is the value of cosine 120 degree? Well, it will be similar to cosine of 60 degree, because if you see for 120 degree angle, the reference angle will be 60 degree, and we can say, well, cosine of 120 degree will be similar to cosine of 60 degree, and then whatever is the sine scheme that we have to deploy here. So let me again scroll up a little bit, and if you think about it, the sine scheme here is that in the first quadrant you see the x coordinate and y coordinate, they both are positive. In the second quadrant, x coordinate is negative, y coordinate is positive, and in the third quadrant both x and y coordinates both are negative, and in the fourth quadrant x coordinate is positive and y coordinate is negative. So if you think about it, in the first quadrant both the sine and cosine function they both will be positive because they represent the coordinates of the point P, and in the first quadrant both coordinates of point P will be positive. That means sine will be positive, cosine also will be positive. If sine is positive and cosine is positive, guess what? Tan theta will also be positive, and also cosec theta will be positive, sec theta will be positive, and cot theta will also be positive. That means in the first quadrant all of the trigonometric ratios will be positive. So now I am going to indicate that with a red kind of notation that all trigonometric ratios for angles in the first quadrant will be positive. So I am now making a note right here. I am writing all. So all ratios will be positive in the first quadrant. Now if you think about the second quadrant, well, in the second quadrant the x coordinate is negative, y coordinate is positive. That means cosine will be negative and sine will be positive. So here only anything to do with sine of an angle, so the sine will be positive. So I am now writing it down just sine. So I am just saying that only the sine related ratios, whether it is sine or cosec, they will be positive in the second quadrant. All other ratio will be negative. So in the first quadrant all ratios are positive. In the second quadrant sine and cosec, because cosec is the reciprocal of sine, so if sine is positive obviously cosec will be positive, but all other ratios will be negative. So in the second quadrant only sine and cosec they will be positive. Now let's go to the third quadrant. There you see that here we have x coordinate also negative and y coordinate also negative. That means sine is negative, cosine is negative. Now if that is the case, then cosec will be negative and sec will also be negative. But how about the tan and cot? Well, tan is actually sine divided by cos. So if sine is negative and cos is negative, then tan will be positive. Negative divided by negative, it will be positive. So actually tan and cot, they will be positive in the third quadrant. So I am now writing it down like this. I am simply writing as tan. So I am saying that okay, tan and cot, obviously cot is the reciprocal of tan. So tan and cot, they will be positive in the third quadrant. Now if you think about the fourth quadrant, well, in the fourth quadrant the x coordinate is positive, y coordinate is negative. That means cosine is positive, sine is negative. So if cosine is positive, then only cosine and secant, cos and sec, those are the two ratios that will be positive in the fourth quadrant. All other ratios would be negative, because if you think about it, is the coordinate of P, the sign of the coordinates of P is going to dictate the sign of these functions. The way these two functions have been defined, the sign of the coordinates of the point P will dictate the sign, meaning whether it's positive or negative, that kind of a sign of these two functions, of sine function and cosine function. So every time you have to find the sine or cosine of an angle, all you need to do is first you need to understand in which quadrant it is, and then you draw a quick little picture, and then you can easily find out what would be the value of sine and cosine in that quadrant, right? Or sometimes you could be given the coordinates of a point P on the unit circle, and then you will be asked to find out what is the sine theta and cosine theta. It's very easy. X will be the cosine theta and y will be the sine theta. Now in this case, if our alpha angle was 120 degree, then sine of 120 degree will be same as sine of 60 degree, and cosine of 120 degree will be same as cosine of 60 degree with a negative sign. Of course, it will be negative cosine of 60 degree, and that 60 degree is the beta angle, which is called the reference angle. Beta is the reference angle, which is an acute angle between the terminal side and the x coordinate. Whatever is the x coordinate, we have it nearby. The acute angle between the terminal side and the x coordinate is actually the reference angle, and using the reference angle we can find out the different trigonometric ratios using the sine and cosine function. So now that we are talking about unit circle, now we are going to call them functions. So sine function and cosine function, and no matter how large your angle is, well, if you have an angle, say suppose 390 degree, from there what you need to do, you need to first find out the principal angle, then you find the reference angle if we have to, and then you find the sine theta and the cos theta, right? So let's take an example here. Say suppose we want to find out the sine and cosine of 390 degree, for example. So we say okay, sine of 390 degree and cosine of 390 degree. We want to find those values, right? Cosine of 390 degree. Now from this 390 degree, for 390 degree, what is the principal angle? Well, from here we can say, okay, the principal angle would be, so if I simply write P dot A dot, so that's a principal angle. The principal angle will be, we can subtract just a 360 degree from it to bring it down to in a range between 0 to 360. And you can watch my previous video where I talked about the angles. There I have explained this very well. And so the principal angle will be 30 degree. Now 30 degree is within the first quadrant. So what will be the sine of 390 degree? Well, sine of 390 degree is same as sine of 30 degree. We already know how to find the value of sine and cosine, all these ratios of the standard angles. So that is how we can do it. And similarly, cosine of 390 degree will be same as cos 30 degree, right? So the steps are like this, that we want to find out if the angle is larger than 360 degree. First you find out the principal angle, and then if the angle is greater than 90 degree, you want to find out the reference angle. So step number 1, let me make a quick note right here. So the step number 1 would be, if necessary, find the principal angle. For a given angle, find the principal angle if necessary, meaning if the angle is larger than 360 degree. And then step number 2 would be, find the reference angle if the angle is greater than 90 degree. Now when we have to find the reference angle, if the original angle is greater than 90 degree but less than 360 degree, that is where we have to find the reference angle. Now if the original angle is greater than 360 or less than 0, then first we have to find the principal angle, and then we have to find the corresponding reference angle. And then using the reference angle, we can calculate the value of sine and cosine of that angle. Right? So as step number 3, we can say that locate the quadrant, meaning in which quadrant the terminal side of the angle is, and then draw a unit circle and locate the point P, and then final step would be determine the values of the sine and cosine ratios. I hope everything made sense up to this point. Thank you for watching. See you in the next video.